Hello guys, I think I know your question. Everybody's thinking about what's this device. I will answer that later. So if you keep your attention, you will get your answer. I am David Kimr, I am CTO of Unicorn, and my today's mission is to introduce you our mobile-first IoT-Ready cloud architecture. And I will start with some reasoning why we are doing such a thing and what is this all about. So one slide about Unicorn, I promise. We are a company which is working for more than 300 projects. We have for more than 1.5 million users. And we have about 1,060 coworkers which are working in IT. So it's a huge mass of developers. So when we want to introduce some change in the way how they work, it's not so easy. Imagine that you need to teach almost 2,000 people how to develop new progressive web applications, how to switch from C++ and other languages from the patterns they are used to use, and how to make our customers to accept such a change. And I will show you part of our journey we are doing today. We are not only working for enterprises, but we are working for end users as well, because we are proud producers of the Plus4u.net service, which is more than 100,000 users online every day. So we have both large companies we are working for and delivering information systems, and we have common end users, mostly on Czech market, which are using this Plus4u.net service. So, and my mission is to make our enterprise developers, 1,600, to produce and to create progressive web applications with love, And it's not so easy how it could look like, because, for example, most of our developers think that JavaScript is evil. It's not the programming language. It's something you use just to handle your clicks on pages you generate on server, because most of our systems are looking like this now. Not only because we want to develop them that way, but because our customers demand to be them. I can show you. This is how our clients they have to use in work. It's one of the systems we produced now. It doesn't look bad. It looks maybe better than many other systems they have from other vendors. Another one. Actually, this one looks pretty cool, but still no responsivity. Nobody thinks about how to use it on touch-friendly devices, about mobile devices. This is the reality, and this is where we do now most of our money. But in private, all of them are using apps like this. Even in work, I've noticed our coworkers that they are using such an information systems for their work, and next to their laptop, there's their phone lying, and they are using Facebook and other social networks, and they are not prohibited to use it from the big screen, but they simply don't want to, because they prefer to do it on touch-friendly device, and it's better for them. So another example. And the question is, do the enterprise customers want to look at their systems like this? You think they do? I think sure they do, because everything around looks nice, just the working thing, I don't want to say shit, looks like that crap. So I'm sure they want. Maybe they can't imagine it's possible. They don't think that it's possible, for example, to sell and buy electricity across the board from their mobile device, because now they are using big screens and several displays just to monitor all the flows. For example, we are developing systems which is selling and buying all the electricity which is going through the cables to UK and Ireland. So they don't even imagine that it's possible to do it from mobile devices and to do it somewhere else than in the office. But I'm sure they will find out. So we want to be ready, and we are preparing a big change. So we know that all systems, even enterprise systems now, have to follow market trends. So they have to be used from smartphones first. Everything is mobile first. Of course, tablets, laptops, and then the other devices. Sometimes even from desktop computers, if they have them. Many of them still have desktop computers. our younger developers are sometimes surprised when they come to customer sites and they see all those big machines, laying on the tables. And but you can still develop applications which are working both from mobile device and from the desktop on the other side. And IoT comes in place because everybody talks IoT now. Everybody talks about IoT. Still, if JavaScript world is a mess, and there's every month, maybe every week, new framework starting and new standards coming, and the standards from the past week are not true to this week. So IoT is even bigger mess because there are no standards, no frameworks, but everybody's thinking about how they can incorporate IoT in their business. So what we started to do 2 years ago is to develop, one architecture, one framework, one development process to cover all these issues. To develop front-end applications which scale well from mobile device to big screens, to develop servers which can serve data both to front ends and to IoT devices, and if at least possible to develop it with one standard, because if you have 2,000 developers and let them to use any technology they want, it's very costly, very, very costly, because an average developer in our company takes like 4 projects a year. So if he has to switch technology on every project, it means that about 4 months a year he's not productive and he is learning new things, new technology. I definitely push our developers to learn new things and new technology, but it's better to do it, in design time, not during the project, because if you do projects, you need to add value to your customers. You need to earn money. You need to be successful, and only successful projects are that are in time and budget, and that look sexy and work, their quality. So for us, it's very important to have one architecture to cover all of those things. So we call it mobile-first IoT-Ready cloud architecture, and we said that we have to be experts in developing front ends, which will scale from mobile to big devices, to be experts to develop APIs and to develop server-side functionality which can serve all those devices on unified way, and to be experts how to connect IoT devices to this architecture, not to develop some other infrastructure otherwise. So this is our architecture, and I will give you some glimpses how it's organized and what it can do. First, it's not just a framework. Because for us it's extremely important to have end-to-end development process. So it's both components, reference architecture, but process is important, the development process, the way how you organize your work, the way how you test everything around, the way how you teach, how you teach your people this architecture, how you support them when they have problems. So we have to establish all those things for our architecture. And now I think we are in productive mode. So our architecture covers, from technical point of view, like 5 areas. I will touch 4 of them. The first one is front end, And I said this session will be strongly opinionated. So there's first opinion. We think that native applications on mobile devices, it's a temporary thing, because it doesn't make sense to develop the same user interface 3 times in 3 different languages. Because if you want to have your applications to look sexy today, you usually develop one interface in Swift on iOS, then you develop second interface in Java on Android, or maybe Kotlin, because Kotlin is now cool, and then you develop a third one in some JavaScript, maybe CoffeeScript or other dialect of JavaScript for the front end. And if you study application, it still doesn't look like a big mess, but then you want to update the application, and every update you have to do 3 times. And then you touch that if you want to deploy your new functionality, you have different life cycles in each app store. So to synchronize that your functionality is ready at exactly the same time, it's impossible. So still a lot of money, and it slows you down. So if you want to deploy new functionality, you develop 3 times test, 3 times deploy processes, you are slower than your competition, so you're gonna lose. And that's why we think that even on the mobile devices, the future is in HTML5 and JavaScript. So we decided to completely omit native applications and focus just on HTML and JavaScript. And we think that all common mobile devices which are on the market today are powerful enough to support this. Even you have mobile web applications, especially on Android, it works pretty well. So when you install your application on your screen, it looks like a common application. When you switch on your task list, you will find it there. So from the user point of view, it's just a different way how to get an app on your phone, and that's all. So on iOS, it's a bit worse, but still working quite well. So the first strong decision is to do it just once for all the devices. So we have one code base for all front ends in EU5. Second thing, IoT, I will touch it later. And for a server kit, the situation is a bit more difficult, but because we have to manage all the environments of our customers. And the third thing is cloud, because we are used to deploy our systems on premise, because most of our customers are banks, telco, big transmission systems for electricity. So they are used to have big data centers with their own machines and want to deploy on premise. But even that is changing. Most of the producers of public clouds are pushing them. They are giving them very good sales offers. They are meeting the legislation which is necessary for using those public clouds for mission-critical applications. So I think it's changing. So we completely switched the mindset. First, we developed applications on premise, and then we thought about how to put it in the cloud. Now we are developing applications for the cloud, and if it's absolutely necessary, we are thinking about how to deploy on premise. So if you change the mindset, it's still possible to deploy on premise, but it's much easier to deploy in the cloud, and you are much more ready for the future. So uCloud, it's a piece of software which unifies all the public clouds. I will show you. First, about EU5. Our front end, we had quite difficult decisions 2 years ago, which framework to use as a basement. We didn't want to start from scratch, of course. In JavaScript, doesn't make sense. So the finalists were Angular. In that time, it was Angular 1 and React. So we decided for React, not because it was better, but because we had to decide. It's again a strong opinion. We can't afford to support 5 or 7 front-end frameworks, even if they're actually good, because for all of them, we have to have the infrastructure about teaching people, supporting them. So for us, it's important that we have to choose one of the best and stay with it. So we decided for React. I think the decision was good and still valid in this time. And then we did some more decisions, like our people are used to develop applications and generate most of the HTML on the server, to do all the logic about navigation and about it on the server, not just our people. It's in the enterprise world, it's the reality. Most of the systems are developed this way. So we completely switch it. We said that we will do just single-page applications, and all the front-end logic will go back to the front end as it used to be when you develop fixed applications in C++ and other languages. So this decision, it's tough, because before we did, we had a statistics that about 95% of code is made on the server. So it's made in Java, it's made in C#, on other server languages. And just 5% of all the lines of code in a common project was in JavaScript. Now it's 60%. 60. It's a huge difference. So it means that you have to switch most of your developers, more than half of them, to be front-end developers and to be JavaScript developers. So, and the other thing was that it was just 5%. So usually in the project, if someone was too dumb to develop Java on the server, so let's put him on JavaScript. He will sometimes survive, probably somehow. Yeah. But now, most of the important programming and difficult programming, it's done on the front end again. So you need to have first-class developers on front end. And servers became easy, because it's just API, get some data, you store it, or retrieve some data from your storage and send it back to the front end. And all the magic goes on the front end again. But it's good, because if you are developing applications where most of the power is on the front end, even for our customers, it's very good, because imagine that you are coming to your bank and telling, dear bank, here's my device, I bought it. I pay for the internet. Please put your application on my device and use my processor, use my memory for doing your business with me. It's a pretty cool message for all the enterprises that they can do it this way. So they can have much smaller servers, much smaller infrastructure, which is necessary to support such an applications than they had before. So it's pretty cool. And so it was single-page application, and we had to change the design process. We have to solve a lot of things, because if you try to just establish your workspace, everybody try to establish React, Webpack, hands up. Yeah. So it takes days. To have it up and running exactly in the way you want it, it takes days if you start with it. So we can't afford to do this in every project. So we now have workspace which can be set up in 15 minutes. For any developer which is starting in the project, his front-end development workspace is ready in 15 minutes, and it's ready to develop. It's ready to deploy in the cloud, which is done with one command line command, and he can start working and he can start to be productive. So those things were necessary to be solved. On the server side, the situation is different. Yeah, the one biggest of changes I taught you that is 60% of code is now in JavaScript. So it does make sense to develop server in JavaScript as well, because if you try to develop rich front end in JavaScript, lots of lines of code in JavaScript, and then you have to switch to your backend and switch the language. Even if you switch to Java, which is quite similar, it's very difficult. And during the development process, you switch several times a day. So it's a lot of work, and a lot of time you spend on switching languages. So it completely makes sense to develop in JavaScript on servers. Unfortunately, our enterprise clients are not ready to deploy their servers on Node.js, but I think they will, because they will find the added value. So I think the future is in Node.js in that way, especially when still front-end will be in JavaScript. But we have to support Java, we have to support .NET, it means C# of course, and for some other reasons we support Ruby as well, because we have a quite large client base which are using Ruby. So we have our server kit ready for all those technologies, and it's microservice architecture, so it doesn't matter which service is developed in which language. They can cooperate, they have unified interface, so you can have application which deploys several containers in Java, several containers in Node.js, and then it integrates to other application which API is written completely in C#, and it works together. Because of there's unified protocol and unified interface, of course, based on REST and JSON. What else? We had to develop or introduce unified authentication. So we choose OIDC as a web standard. It's OAuth version 2 combined with OpenConnect, and this is a basement for all our servers for authentication. We prepared API Gateway, which can route dynamically a lot of requests, so you can scale your applications dynamically as you need. And that's the next thing about your UCloud. It's a thin layer on top of most popular public clouds. Like first one is Azure, Amazon is there. We have Google Cloud Services, and now we are introducing IBM Bluemix. And the thing is that all of them are great. All of them are perfectly usable, but each of them is different. If you try to deploy your application to public cloud for the first time, it again takes days before you find out how to configure, especially if it's not one server, but you need to have several services connected together. Just the visibility and security, it takes days to establish. So we developed a thin layer which wraps all those public clouds, and when you develop, you don't care if it will run on-premise, if it will run on IBM Bluemix or in Azure. The code is exactly the same to do every line of code. So developers are developing on their local machines. They can deploy their test environment in the cloud. If customer wants to have it in IBM Bluemix, we can incorporate IBM Bluemix, even his subscription, or we can provide it on the subscriptions we have. And it's totally unified and totally flexible. The second thing is, which is very, very important, if you develop applications on premise, you again have different mindset, because, for example, if you are thinking about performance, you have to tell the customer how much hardware he has to buy. So you are thinking about peaks, You add something on top of the peak, and this is the amount of hardware you have to buy. You know, if you deploy in the cloud, so if you're smart enough and you can do elastic scaling, like if your performance goes up, you are adding servers, and if it go down, you are switching them down. All the clouds are usually counted by seconds, so you pay just for the seconds the servers are running. Then you're thinking about the lowest performance you need to deploy. This is what you buy from your cloud provider. And then you establish some elastic scaling, which will add servers as necessary and switch them off if they aren't needed. Yeah? So again, different mindset. And sometimes a lot of companies are doing one mistake when they are moving to cloud, that they are using, you know, the same performance measurements and the same amount of hardware, and they just virtualize in cloud. And then they find out that it's 5 times more expensive. It's the reality. If you buy our servers, even if you count all your people, so in Central Europe, we have long-term statistics, it's 5 times cheaper to have your own hardware with your own people working on it than to have it in a cloud. If you don't do elastic scaling. If you switch to elastic scaling, it's a completely different story. And your hardware always has limits. And if you want to add servers, it takes days. You know, if you want to have to add some performance in Azure, it takes seconds. And for most applications, it's almost limitless. And if Azure is not powerful enough, we have another region which is Amazon AWS, so we can switch the traffic there. So this is very powerful. And if your architecture is ready for such a thing, you can save a lot of money. And the other thing is that the way how we wrap the cloud is container-based architecture, because just to buy hosts in cloud doesn't make sense. The best way how to deploy is to use some containers. We are using Docker and Docker Swarm. So you are developing locally. You have your Docker environment locally on your laptop, so you can test even all your containers on the byte level on your laptop, and then you can deploy to the cloud easily. So those are the 3 most important parts of our architecture, and now we are ready to deploy. Of course, I forgot about IoT. So IoT is important. Nobody knows for what, but everybody knows it's important. Our customers think about IoT, but we couldn't find a business case for IoT. How we will start? So first, we needed some reference application for our architecture. And when you are developing, especially on front end, it's a long-term tradition for every framework that they will introduce an eShop. If you think about all the frameworks you saw, Ember.js, .NET framework, ASP.NET, all the reference applications provided from the vendor were usually eShop. So we decided to provide as a reference architecture eShop as well. So we introduced this IoT device. First, maybe I will show you the eShop. Live demonstration now. Yeah. I'm brave. Okay. I will just check if I'm locked. Let's switch to English. Yeah. And this is a very special eShop, you know. It has just 3 products. It's a pet eShop, you can see. It has a special thing for dogs. It's rabbit ears. I have 3 dogs, they love them. You know, so if you want them to behave nice, you can show them rabbit ears. They are okay. Yeah, so we have rabbit ears for dogs. There has to be something for the dog lovers as well. So we have a smoked knee there. Yeah. And something for mice as well. So we have gummy bears, just these 3 products. And you can buy it, of course, from a mobile. Nobody on a Reactive conference will be surprised that if you switch to smaller factor, it will work completely mobile and everything changes. That's perfect. Yeah, but it's not the most funny thing on it. But what if your dog could order their goodies? That would be nice, isn't it? Yeah. So we developed this device. You know, it's based on Arduino, and if a dog comes to this device and barks, it will order rabbit ears. You can try if you want. Anybody want to bark? Don't be shy. Yeah, but you can't bark from that side because then your neighbor's dog could order. Yeah, so there's a proximity sensor. So the dog has to be about like 50 centimeters from the sensor. So we can try, or maybe I will show you the orders. It's very easy. Many orders. Yeah. And we will try if we can order. Of course, sometimes even the dog lover want to order, so there's a special button. You know, it's made on the 3D printer, of course. So first we can try if I can order some smoked knee by it. It's connected through Wi-Fi, and it was okay. So we should see in a couple of seconds that there will be another order for smoked knee, and we can try to bark, but you know, sometimes it's good enough. Okay. Here's new smoked knee, and now our dog is coming. Students in our university built this. It's perfect, you know. Of course, it's not production ready, yeah. But you can imagine that if you have such a prototype, you can order some guys in China and they will produce this in millions and it will be this size. So there's no problem with the design of it. If it works, it can be can be small and it can be productized. We just need to find out enough dog lovers which will allow their dogs to order their food by themselves. Yeah. So and it's here, you know. So this looks very funny and very easy, but it's a prototype how it can work. Actually, it uses Microsoft Azure Iot Hub to connect to our architecture. Yeah, I see Microsoft there, perfect. Yeah, very good technology. And most of our cloud runs in Azure now. So, yeah, but you can do it with Amazon IoT as well. I'm not ready to show you, but you have to believe me. And this IoT Hub is perfect because this is something which can unify the mess of IoT things, because it can, you know, there are a lot of standards about connect IoT devices and a lot of protocols. And if you want to do it by yourself, it's a lot of work, a lot of maintenance. And IoT Hubs integrates now about 6,000 devices, 6,000 protocols. So you just connect your IoT device to IoT Hub, and then you have unified interface how to communicate with it. So this is the way how you can, for example, integrate IoT to your application. And this is our eShop, and it's working. And now when I switch to more slides, because we are at the end of the presentation, you can see that many more applications are now developed in this architecture. Actually, we have 5 applications running in Skoda Auto, which is the biggest car provider in Czech Republic. For example, application which is used for all the authorized services around the world, just using our framework, you know, to check in the car in the service and check out, and many more. So now about 5% of our clients are using this architecture, and we want to persuade them that each of them should start their applications to be mobile first, IoT ready, and running in the cloud. So if you have any questions, now this time, or I will be outside for a couple of minutes, so I don't want to block another speaker. So thank you for coming, and hope I see you next time. Bye.